Hey everyone, welcome back to our series on Bifrost for Maya. In this video, we're going to show how you can array objects inside of a volume. The last video covered how you could array geometry over a surface using scatter points. In this video, we'll cover a related compound called scatter in volume that does just what it says. Unfortunately, this component is not available by default in the Bifrost list. What I mean by that is when you hit tab and search for components, you will not see scatter in volume by default. However, at the end of the video, I will show you how you can put the compound in a special folder in your users directory to make it available each time you start Bifrost. But there's another way to access it, and we'll be making this little voxel tower using that method. So let's go ahead and get started. So I'm going to create a new scene. And instead of creating a graph, I'm going to grab the Bifrost browser and look in the scatter pack section. And here you'll find an example that shows scatter in volume. And we can either open an example scene with this, or we can just import the basic compound. And I will do that, hitting import. And now we have an example here, and it's hidden, but it seems like we have a sphere here, and inside the sphere are scattered points, and then they're being filtered with a fractal noise field. So all of this should be familiar to you from our last video, and we're going to just go ahead and modify this to make our little voxel tower. Okay, so we don't need the input. The output, I'll just move over here by our terminal. And what we really care about is the scatter in volume. And so I won't delete the fractal noise field. Maybe we want to play with it, but I will unlink it. And then you can see the way that the points are scattered very densely inside of our sphere. But we don't want to use a sphere for this example. We want to use a box. So I'm going to, in the Maya modeling window, create a new box. I'm going to zoom in on it by hitting F. So here we have our little cube, and this will be the basis of our little voxel tower, the one that we scatter inside. So let's pull that one over by middle mouse button dragging the cube into the Bifrost browser. All right, great. So we want to scatter this into a volume, but I'm going to use this as an instance. So I'm going to put this one over here, and then let's make a bigger box. So that one's copied on top, but I am just going to move this second box out. So I've made a second box. Let me go ahead and show the edges of our geometry. All right, so now I have two boxes, and I want this one to be much bigger. So hitting the R key on my keyboard, I'm scaling it up, and I'm just rotating, and W, moving it over. So this is what we will scatter inside of. And to make our tower, we'll eventually change the proportion of this box. But let's just leave it as a cube for now. And so this is going to be our, I don't know, let's call this our tower shape. And I'm going to middle mouse button drag that shape node into our graph window. All right, so I'm going to go ahead and Control H, hide that object, and then in the graph window, let's put our tower shape into the input and scatter in volume. So bring that over like so. And you can see now all of our points are scattered in the volume. Now, if we don't want to visualize these points, we can toggle that off here, and this should, we also need to toggle it off here in the terminal. So let's just show that even if you don't have a terminal, you can toggle on a visualization of the points here. I'm going to toggle that off, and now let's use our instances. So like we did last time, we will use the set instances, set instance geometry tab here. So then I will bring our points into that, And then the little box, our first cube shape, I will bring into the Instance Geometries tab here. And then let's just unlink everything from the terminal that we have here. And of course, if you don't have one of these in your graph, you can just hit Tab, type terminal, and get a new terminal. All right, let's bring our instances into the proxy tab, and now you can see we have a gazillion little boxes inside of our bigger box. All right, I'm going to turn off everything but the proxy preview here, and then we are going to make sure that we can bake these out and make sure that they scale correctly. I'm going to hit Tab and use the Bake Instance Geometry compound. And I will bring instances into this, and then I will just replace our proxy instances with that. Okay, and what you can see is that our boxes get bigger, and in fact they go back to the shape of our original box. And I'm not sure why when we set the instance geometry that it shrinks down a little bit, but it's always good to both set and then bake the instance geometry at the same time, because if you start changing the scale of things and then bake everything out, it will change and it will be annoying. So we don't want that. Okay, so now we have scattered in our volume. We have way too many cubes here. So let's go to our scatter settings and amount. So we could come into the properties window here and find the amount number, but it can be a little bit cumbersome. So let's go ahead and create a value that we can use to change the amount. So we could hit Tab, type value, and link up a value that way. Another way to do this is just to right click this port, and at the bottom, we can create a value node, and then it is going to create a value node with the value that we have already in this component. And now we can easily just grab that and slide it. And so now we are sliding down the number of our little boxes here. So far so good. Now we need to change the scale of our boxes. So how do we do that? Let's come between the scatter in volume node and the set instance geometry node. And we want to add another compound, and we will call this one, or this one is called randomize scale. So randomize point scale. And like I pointed out in our last video, the information about scale, rotation, all resides on the point. And so we don't actually scale the instances directly. We put that information on the points, and then whatever instance reads on the point data, whatever each instance reads on the point data gets translated here. Okay, so we randomize the point scale, and now you can see we have boxes of various sizes in here. We're not controlling that yet, so let's go ahead and pull this stuff out, and we can, under randomization here, min and max, let's go ahead and right click and create a value node for each of these, the minimum and maximum. So 0.5 will be our min, and then actually I'll just Control C, Control V that, and use this one for our max. And now we can link this up here. We can put a larger value, and we can use this as a slider as well. So now you can see that we're controlling the scale range of our boxes. So this is a great first step. Let's also put a global scale on this, and we can do that after the randomized point scale. We can just put a normal point scale. So point underscore scale should be, just type scale. What is it? Scale points is the name of the compound. And linking that up here like that. And then let's go ahead and get a value node, create a value node for this one. Oops, well, that's interesting that we're doing it that way. So this is nice because it's giving us a float. So this is showing us that we could actually scale these independently, but that's a little more than I want at this moment. So let's go ahead and create a value that's just a float. A float is a floating point number, and we should be able to put that into scale. And then if we have this, say, as 2, right? Now with this, we can globally scale all of our boxes. So we can scale things here with, we can assign the range here from large to small. And then we can, once those things are sized, we can globally scale everything up and down. Okay, so I think this is taking us pretty far towards our tower. What we would now need to do is change the shape of our input object so it looks a bit more tower-like. So I'm going to show that by hitting Shift-H, selecting this. And if we want to have it visible, but as an outline, in the channel box, we could create a layer for this object. And if we set it to T, and I'll call this layer input, or what would we call a tower input, something like that, tower input, save it, great. And so we can't select it, but in the modeling viewport, but we can still select it here. And now you will see, let's open Bifrost again. Well, for this step, we are just going to select this object, hit WER for scale, and now you can see that as we change this, the scale of this object, all of our little boxes change. And so maybe we now want to make everything a little bit bigger. And we could also think about how many of these objects do we actually want for our tower. So let's scale things down just a little bit more. So scale these things down and maybe come back to our minimum value and scale those things up a little bit more, and come back to our density and add a few more in. And what's interesting here is that we could think of this at perhaps the scale of a building. We can make it taller. We could also think of this as like some sort of interesting wall. So if it's skinnier like that, but wider, we could make something like this. And then if we wanted to, we could go ahead and grab our the number of objects and make it denser. So there are a lot of ways that we can think about this. It doesn't really have a specific scale, and that's interesting for our for the way that we could think about using this for design. Okay, so this is pretty cool. Now for the randomized point scale, what I'd like to point out is that right now we're uniformly, we're scaling everything individually. Let's bring the scale of the biggest ones down. We're scaling everything individually, but we're scaling everything in X, Y, and Z. It is possible if we select the randomized point scale compound here, axis to scale, you're seeing that we're scaling everything uniformly, but we could choose to scale, the x-axis only, or the y-axis only, the z-axis only, or we could scale these things separately, and that's interesting as well because then it gives us a variety of box shapes. They all start as cubes with this basic input, but by changing how they're scaled, we end up with boxes of a variety of sizes, and that's also really interesting. So you can play with that. You could probably randomize how much each axis is scaled. And there's also this distribution curve, which we can play with. And it's not a little hard to grab there. So let's minimize this a little bit, make this a little bit, whoa, a little bit smaller. That's not working at all. So let me just see if I can get this distribution curve to pop up here. Okay, well, I don't have enough screen real estate to show you how to do this, but there are these preset curves here. And if you try these, you can, let's try something like that. It's a little bit difficult to see what's going on there, but it is changing the distribution of how they're being scaled. And we could change that. So I'm thinking if we played around with this a little bit, we could maybe get some interesting effects, but I don't have full access to that curve. So we're just going to leave that one alone, and we can take it back to the constant. All right, cool. So now that is pretty much it for this tutorial. Maybe we want to rotate these things. Let's go ahead and just show how we could do that. Let's add some rotation to this. Bring our randomize. Let's see, randomize point rotation. So let's grab that. Points. Okay, so now these things are randomly rotating. And as I showed in the last video, we can right now, so this is in radians by default. And I don't think that we can change it to degrees, but you'll see that it's not rotating very much in X. It's rotating the full range, so 3.14 is pi, so we're getting the equivalent of 360 degrees. And then here we're not getting that much. So we could actually just get rid of all of the rotation in X and Z. And now these boxes are just spinning around the up axis, which is the Y axis. But if we wanted these things to scale more dramatically in X and Y, we could paste these values like that. And now we're getting a real jumble of boxes. So I'm going to take this back by hitting undo. So let's take this back to 0 and 0. And now our boxes are just spinning around in their vertical axis. And let's see here. Let's take our tower shape, WER, and just bring this down a little bit, scale it down, play with the scale, and then maybe play with the number of objects in this. Take this value down, and we can continue to play with this and make this whatever we think looks interesting, maybe something like that. Okay, I think that that's what we need to cover here. If we want to bake this out, we can put our merged meshes into the output tab, and then we can right click the merged meshes, create a Maya mesh. So again, right click, create Maya mesh. That Maya mesh will come into the modeling area. We can center its pivot and then move it over. It's always a good idea to mesh display harden the edges so that it matches what we're seeing coming out of Bifrost. And then by default, this will have a live link to Bifrost. So if I start changing the scale here, my merged meshes in the modeling viewport will change. And then if we want that to, if we want to break that link, we can use that with deleting the history, freezing the transformations. It's deleting the history that breaks the link, by the way, but it's good just to press all of these. And now we'll have something that will stay the same, and we can change Bifrost. And then this is something that you could continue to work on manually. So that's scatter. That's the basic application of scatter and volume. And again, if I hit tab, you will notice that I have scatter and volume and some other scatter options accessible. If you want these to be available by default in Bifrost, I will put in the description of this video these standalone components, and you can grab them and stick them into your users folder. So If you are on a Windows computer, if you come to the C drive, you can find the users folder, and then whatever is your default user, you can put this little Autodesk folder, and inside that Bifrost compounds, and then you can put the special compounds. And if you locate the compounds in your users folder, then every time you open Maya and Bifrost, they should be available. So I will pop that in, I will drop that into the description of this video, and you can unzip them into your users folder if you want. Thanks for watching.